Hello, welcome back on my channel. This time I'm gonna try to repair this MFJ 1025 noise canceller, the one on the top. I recently acquired this unit as very cheap for repair. Doesn't work. I happen to have the one on the bottom, the 1026. The only difference between the two is a hole up here, as you can see, because in this hole you can screw in a telescopic whip, and you can use an internal preamplifier. In fact, you can see 1026 has a preamp on switch in the front panel, which is not in the 1025. I must admit that the internal whip is not really needed unless you have the source of the noise very close to the station, and your receiving antenna is also close to your station. But if that's the case, most likely noise source is in your house, so you better remove the noise source. Apart from that, the preamplifier can be handy when you're using the auxiliary antenna, because sometimes the aux antenna is not as sensitive as the main antenna, and if you don't pick up the noise with both antennas, the unit doesn't work properly. So sometimes switching on the preamp on the auxiliary antenna is really essential. Okay, this unit is a little dirty. It's got a bend in here, probably has fallen, and I see some of the feet are missing, but that is not a problem. I see the screws are not original. This one is original, the other ones are not. This also can be fixed. Yeah, apart from that, it looks okay. So remove a bit of dust and I'll open it up to have a look inside. Okay, so let's take a look inside. Okay, obviously somebody was in there previously. They write down all the labels for the ports. I don't know why. These are well clearly written here at the back. So the back looks good. Yep. I can see something going on here. Two flying inductors. These two L1, L2 are 100 microhenry inductors. I just replaced these two on my units because they blew up with a lightning strike I got in my station. There's a flying diode. Also, there's a pad missing here. I have to have a look. I'll remove these first. The lamp, this is the lamp for the RF getting back to the auxiliary unit when you transmit with your main antenna. Some of the RF could be picked up by the auxiliary antenna. If it's too much, you'll see the light coming on. This is also, I don't know, it's soldered, but yeah, strange. It normally is also glued to the PCB with some sort of glue, but nevertheless. What else? I see, what else can we see here? This capacitor, electrolytic capacitor, is not straight, but the solder looks original. Anyway, this Q7 transistor looks also is not straight. This resistor R32 is lift it up. It's not touching. I don't know why. No idea. Anyway, looks that's all. There are some missing parts regarding the circuitry for the preamplifier, and for there's a jumper here in here. The whip goes in here with a screw. The switch for the preamp is missing. I want to try and make this a 1026. So I'll buy the switch and make a hole, and I'll add all the few components that are needed to make it a 1026. In fact, you can see the PCB says 1026 is basically the same. So they make two models, two market prices, but they are basically the same, just different, labels. Okay, I'll start removing these parts, and then I'll desolder everything and remove the PCB. To remove the PCB, I'll have to first remove the knobs and then the nuts, so the potentiators are free, and you can lift the PCB up and slide it out. Also, there are a few screws at the bottom, 1, 2, and 3. I have cleaned all the writing in there. Also, I have cleaned all the everything basically with the dish soap. It looks much better now. No grease. I straightened the corner. It was this one and also this one here. Obviously, there are a few scratches in there, but doesn't have to look new. Just in good shape, and I think it's in good shape now. I'll go now to cleaning the PCB, and I'll go ahead. Okay, so I'm ready for testing the functionality, also to explain a little bit how to work this unit properly. So here we have the signal generator, 14.2 megahertz. I will later check different frequencies in the entire range of the HF. The signal is coming out and is going through a splitter where the signal splits in two parts, and one goes to the main antenna port and the other one goes to the auxiliary antenna port. In this way, I'm simulating the fact that one single noise source, which is the offending signal or the noise, comes to both antennas, the main one and the auxiliary one. And this is really key in having the unit working. If you don't pick up the noise with both antennas, you cannot cancel it out. So, and obviously it can arrive with a different phase. So it doesn't matter how long is the coax line here, because in reality the signal comes to the antenna in a different phase, also in different polarization. So that's totally okay for the test. I will generate a 6 dBm signal, nice and high, so we can appreciate then how much we can attenuate, changing the range on the millivolt meter. Okay, so I'll position the camera here. I put 6 because of the splitter, which splits in two, is a resistive one, and 6 dB lower on each side. So we have about 0 dBm here on the radio port. And have a look at the setting. So I'll put the auxiliary antenna down to 0, and I'll crank up the main antenna, and I'll switch on the unit. So what we want to do is imagine that this is our S meter of the radio, and we can think that the needle is pointing to whatever indication, let's say S7 or S5, whatever is the noise level on our radio. We turn the main antenna gain down, all the way down, and then we turn the auxiliary antenna all the way up. And as you can see, we cannot reach the very same level. So in this case, we could use the preamplifier, which is not in this unit, so for now. So what we can do is take note of the level on the hypothetical S meter of the radio, here the millivolt meter, of the auxiliary gain, the lower one. So let's say it's an S4. Okay, so turn down again the gain and go back up with the main antenna gain until it is S4. About there. I just can't remember exactly. Yeah, it was -2. Okay, so about there, -2. So now we know that we made the signals equal in amplitude. So I'll crank up also the auxiliary antenna gain now to the maximum, and as you can see, the signal has already dropped. I can check with the phase now, and the signal is going down and it's going to a dip. Let me change the scale. Okay, we can find the dip here. Okay, let me now play a little bit with the gain. With the gain of I lift the auxiliary to the maximum. This is a problem with the potentiometer I have to solve later. Let me play with the antenna gain. Okay, so I'll lift this to the maximum, and I'll reduce here, and as you can see, we are going down. I change another scale, another 10 dB scale on the voltmeter, and we're reaching a pretty high attenuation. There you go. Another scale, and I think we have reached a good result. There you go. Amazing. Look at this. I've reached a very good result. This is very touchy now. It's like a notch filter. So we started from -2 on the 0 scale, and we went down 10, 20, 30, and then 1, 2, 3, 4, 5, 35 dB of attenuation. That's a very nice result. Okay, that's all for now, I would say. I'll make a follow-up video when I receive all the components that I want to buy for the making the preamplifier circuitry. Today I bought the switch, and then I place an order for the components. And in meanwhile, I will work on this part to make it a little better, and that then I think that's all. I think the unit then is ready to work again. So I'll see you in the next video. Thanks for watching. For now, all the best, and 7-3.